Yeah, do all six, please. Make sure you're doing okay. Yeah. Doing all six. All six. Oh, you don't even sign. So you have to try to then the fourth project. Okay, I'm calling a couple people, well, three people to start with. Kieran, what is 10 inverse of 0? Is this true?
Yeah.
Is there another answer?
No.
Is pi also an answer?
No, it has to be between
Between negative pi over 2 and pi over 2. So although it's true that the tangent of pi is 0, we're just concerned about the values in a very particular spot. Let's take a look at our graph and make sure, is it true tan inverse of 0 is 0? Yes, very definitely. Tan inverse of 1. Nola. Do we agree? Is that the only answer?
Yes.
Well, there's one other acceptable answer.
45 degrees.
45 degrees is acceptable. Again, I forgot to ask you, is 0, is that degrees or radians? Oh, so efficient. Okay, thank you. Thank you, Noah. And Miles, tan inverse of -1.
Negative.
You sure about that? You sure about it? We're good? Another possible answer would be -45. Which means, of course, on your graph, if you wanted to, instead of calling that pi over 2, you could call it 90 degrees up there, right? Depends what language you're speaking. Negative 90 degrees on the bottom. Just however you're thinking about it. Oh, did you already do these? Let's see. Brianna, were you able to do this first one? Okay.
I know make a triangle.
It's definitely not a unit circle. That's good. Okay, and where is this angle triangle going to be located? Do we agree with that fourth quadrant?
I would agree.
How did you know? Yeah, we know that for inverse tangent, it's either gonna be in the first quadrant, fourth quadrant, it's negative because everything's positive in the first quadrant. Okay, so where do we go from here?
The axis. So it's four this way and down three.
So for this way and down three, so negative three like this? Do we agree?
And it's a 4, 5, 20%. But a 5.
We could, no real work necessary there.
And then. This part of. We can find a sign of that, we could just be. Which would be.
Are we good with that? Negative 3/5? I like how you say you're not sure about it, and then you have exactly the right answer. Nicely done. All right, remember when we see tan inverse, sine inverse, and cosine inverse, what we're referring to is an angle, yes? Specifically, in this case, an angle whose what ratio? Tangent ratio is -3/4. So the angle we're talking about, if I want to put it in here, is it okay to put the theta here? Is that okay? As long as that angle is in standard form. Is that standard form? Yes. Very definitely standard form. And one thing we know about the value of that angle is acute, less than 90 acute, and you know one other thing. I guess it's negative. What's that? It's negative. Is it negative? Yeah. Do we agree? Standard position, that's negative, isn't it? Let's calculate that angle, shall we? Let's actually figure that out. That's not a place, not a standard place on any circles. In order to calculate it, you're going to need something called a calculator. So theta is equal to inverse tangent of 3/4. Would you please calculate the value of that angle? See if you can figure it out. Maybe like
And if it's 3, 4, 5, it has to be a.
it's not
That makes so much sense, like on this point, and I'm like, the angle, that's how you guys do. Okay, and then.
more than, but we don't actually. More than sign. 36. Second the neighbor, make sure they got the same thing you did. But did you get anything? 0.64. Did anyone else get that? I'm sure that's wrong.
36, 36.88, 36.9.
Because I know the answer has to be negative.
Negative.
So did you mean negative 0.64? Oh, I'm sorry.
I know about that.
Oh, wait, were we wrong?
I was wrong with what I wrote up here. It's inverse tangent negative before. So, but I think you're right about the value. It's negative 0.64. Is that right? Negative 0.64. Definitely not degrees. That'd be a tiny little angle, wouldn't it? Radians. Okay, and about 36 negative 36.87 degrees. Were we all able to get both of these?
Yeah.
So please make sure you're being intentional about the mode that your calculator is in, and you know how to see if you're in degree or radian. Just by looking at it. You know how to see it, right? That information is at. It's at the top of the screen. Do you see it at the very top of the screen? It says that you're either in degree or radian.
No.
It should say at the very top of the screen. Oh, if you have a, it's okay. We still accept it. Hey, before we move on, for this problem, was it important to figure out what things are like? No, definitely not important, but you can see how maybe on a test, if you get caught up doing something like that, I'm probably not necessary. You're gonna be wasting it. So just make sure you think that only necessary. Another reason I did this was to see if we could do that. I was literally going off on a tangent there. Okay, a secant of tan inverse of 1/2. Brandon, can you help me out with this one?
Answer in the whole process.
I can't just get the answer. I need the process.
So I made a prompt. One thing that first
Okay. So something like this.
so the opposite, they would be like private one.
Oh, so theta's right here.
So the opposite.
Thank you for bringing these words opposite and adjacent, because that's tangent. That's the essence there. Okay.
So then I would at that answer and found that I thought it was 35.
Are we on board here?
Yes.
Okay. So cosine of theta is equal to 2/√5. Okay, I like that. And then are we good? Any questions? Nicely done, Brandon. Thank you. The only thing I recommend here, you did a really good job. Cosine, I want to bring those ones you talked about adjacent and hypotenuse. The cosine is adjacent of my hypotenuse. The secant is hypotenuse. You don't have to do one over it. Although it's exactly the same thing. You get the right answer. I just want you to think about it that way. As an aside, a student came into the math office a couple years ago. This was from an honors pre-calculus class, and they were going over some trigonometry. And the teacher said, okay, we're talking about this angle. What quadrant is it in? She said it's in the first quadrant. So she said, okay, can you make a triangle in the first quadrant? So she did this.
It is correct.
It is correct. She's not wrong. She drew a triangle in the first quadrant, but you can see that the concept and application of it was is a complete miss. This is honest.
No, who was the student?
Yes.
Who was the student?
Graduating class.
It was sometime in the 2000s, like sometime since 2000, not before 2000. Yeah, I'm not going to release the name, but maybe it was Johnny. Maybe it was Johnny. I don't know. If you know of a student who did this, contact me. Okay, this one. Last one. Oh, man, too good. Chazzy, we need your help with this. Can you help us out, please?
So I didn't get.
I like that. Can do.
I guess you could say, if it's just today, you could say it's real one.
Oh, well, do I need a figure here or something?
Yeah, so you got I will in the first one.
Okay.
Connected to you.
Oh, okay. I'll pretend I know what's going on here. Okay.
Yeah, so it would be like the opposite would be 3. And then on each.
Thank you for making a fraction there. Cool.
And then find the full time. You have to get the hypotenuse.
He's talking it out. It's okay. Chazzy, we're with you. Don't listen to the haters. You're doing great.
And then you can find out.
Okay, which is okay. 1/√10. Are we good leaving it like that?
Yeah.
Does it make anyone uncomfortable to leave it like that?
Yeah.
You want to rationalize that? Yeah, you may. But if you rationalize it wrong, there's nothing I could do about that. You're taught to always rationalize. So √10/10. That's fine too. Okay. Hey, look at this. We have 3 new parent functions. Did you bring your pocket sign inverse?
Yes.
Will you please show me your pocket sign inverse?
I forgot it was like 4 years. Oh,
From your point of view?
So, yeah, I think it is.
It might be full body.
Like,
Is this it? Something like that? From your point of view? Where the origin is, like right here. Discuss the neighbor, what's that have to do it?
So, that's after. What's so funny? What is so funny? Oh, it's just Japanese.
Okay, so
What does this Q here do? Show me what that does. We know it's a vertical stretch because it is. Function, this Q here on the inside is going to be horizontal. Compressed by. And this is a vertical stretch by factor.
two, of course, I'll give you a chance to do that, and I will be asking for one lucky student to help me graph that in just a moment.
I think like the same or horizontal stretch by factor 1 times.
It's I understand what you're saying.
Yeah.
You're using the factor of 1/2. More appropriate would be dilation of 1/2. If you want to apply to this stretch or.
Oh,
Don't you worry about the.
I know, I don't want to like that. I think it's.
Even though 10 seconds to finish it,
Oh,
you're graphing it.
oh, wait.
Okay, so Andrew, can you help me with graph this one? Like, what should I do on the x-axis? Yeah, what should I mark?
Period.
So period, is there a period here?
No, I meant.
Don't go back to the signs. Don't go back to the signs.
I meant, the graph is from -0.5.
Yeah, okay, I'm gonna say -1/2 just because I'm old school like that, but yeah, -0.5, okay.
And then the range is from -5.
How did you get pi? And it,
Range. No. Stretch, no.
perfect, so we doubled up the y values. Yeah, easier done than said when it comes to math, isn't it? Easier done than said, but yeah, that's a great explanation, thank you. And we have this, and once again, can you picture this as a sine wave that's slinking up the y-axis? Just to make sure that the curvature is going well.
Like it's a little sine wave. It's going up, that. It has to be 1-to-1 responsive.
How do we do the curvature? Like, is there a number in?
Yeah, the basic one? Yeah. Looks like a piece of the sine wave is going down. Yeah. I think that is cubics. That's a cubic.
Oh, I see what you're saying. I think. Oh, my village lit.
I don't think it's a sine wave. Similar, probably. So Karen, the other thing that you might see is, and one of my university professors did this, and I was really annoyed when they're doing sine inverse.
And can you imagine going up and trying to go up the y-axis with this, like trying to make it sine wave? It just starts in the wrong way, doesn't it? It's got, it's sine wave this way. Over at, then you try to go up the y-axis. You can't see if you want to, it's just up the y-axis. So I do want to get attention to that. I'm looking for these 3 points, but if this is what you use graph, you get most of the credit, but if you didn't, you for having it.
So if you had a. If it was a negative cubic sign, would that not have any difference, or would that flip the inverse, or would it flip the original and move it?
We have a new parent function, that's why you're very happy with this. Like, so if it's negative sine inverse of x, you take this and flip it over y-axis. Of course, if it's sine inverse of negative x, we take this and.
Well,
Well, if it's sine inverse of negative x, you flip it. Which would result in the same thing.
yeah.
We would also be like, that point off of issue, if it's wrong, would be incorrect for arrow? Yeah. Yes, yes, definitely. Yeah, good point, thank you.
Do I need some closed dots up there to make it perfectly obvious that we end there?
I would say so.
It wouldn't hurt, but I'm not gonna take off points if you leave them off. It's fine. Okay, so in summary. Where are we? Let's go up here, page 12. Let's just have it like a graphic organizer of which angles we should be looking for sine inverse, cosine inverse, and tan inverse. You just check with your neighbor, where is sine inverse or cosine inverse or tan inverse? Thank you. I was surprised.
Wait, what are we doing?
Discussing which quadrants are active for sine inverse, cosine inverse, and
Sine is one of four, cosine is one of two. If we're looking at moving to that means we're talking about cosine, maybe cosine. I think that's inverse.
yeah, exactly. So I'm just gonna make a little graphical organizer here. I'm gonna say cosine inverse is here. Right, from there to there. Does that make sense? Cosine inverse is just only there. And then of course, both sine and tan inverse are found in the first and fourth quadrants. So I'm gonna put here sine inverse and tan inverse from here to here and here to here, just kind of as a quick reference. Does that make sense? It's kind of a summary of where all these angles are found. Please don't look outside those angles when you're dealing with these three functions. I know, poor quadrant 3, never. Forever alone. What's that? It's just too far away from 0. I think that's the problem. Okay, one more question for you. Oh, yes. They coincide with their parents. Okay, so again, one more question for you. I have an equation for you to solve. I know this is exciting. 3 sine inverse sine of x is equal to 2 pi. Let's make it equal to pi. It's equal to pi. So solve for the only variable is there. Solve for x. Discuss with your neighbor when you are at a place where it's reasonable to discuss. Did you get something? That's the first step you did was to divide by 3. So we get a sine inverse of x equals pi over 3.
So for those of you who like to use intuition, you can just go ahead and things here. Don't forget what this x value means. The ratio. What kind of ratio? Sine ratio. This is asking what is the sine ratio of the angle? Pi over 3. No, that's the sum of the angle is pi over 3, and that's the sine ratio. You know what that is? Root 3 over 2. Yes, yeah. So that's kind of intuitively. I don't think this is like really about it, something like this. I would just come to it out of that. Do you have a chance to find numbers?
Multiply by sine.
It's not that you multiply by sine, but we take the sine of both sides. The sine and sine inverse do cancel each other out as long as there are no domain issues. So sine of pi over 3, am I done with the question here? No. Yeah, we know what sine of pi over 3 is, so let's finish it. Sine of pi over 3 is root 3 over 2. So whichever way you want to think about it, it should get you to that answer. I need some time to work on the 2 assignments. You have to finish the one from last time. And there is a 6th problem assignment, new one, that includes some tougher problems.
60.
Yeah, exactly. 6, but each one has z portions. Yes. Oh, they were due on Monday. So if you last Monday. Yeah, if you didn't give me your test corrections, please do so now. No problem.